let's do some problems out of section 2.1 of our textbook that help us work with complex numbers. So I want to do these problems off page 317. We'll start with these ones. So here, number 6, the instructions on the first few here are to add or subtract as indicated and write the result in standard form. The next few, starting with 14 and 16, the instructions are to find each product and to write the answer in standard form. For all of them, I'm just going to perform the indicated operations. So in this first one, I'm going to start just by distributing these minuses. Now I can combine like terms, and I have 2 imaginary parts, and then I have 3 real parts to add together. 6 and 5 give me 11, 13 more is 24, and then minus 4i plus 1i is minus 3i. So I end up with a real part of 24 and an imaginary part of minus 3. Moving on to number 8, again I'm going to start by distributing. Imagine distributing that minus into both parts. I need to combine the imaginary parts. I'll have a plus 26i and still have that minus 12. Real part of minus 12 and an imaginary part of 26. Oh, the next problem I want to do, number 14 there, we'll need to multiply these 2 complex numbers together by distributing. 8 times minus 3 gives me minus 24, plus 72i, plus 12i, and finally minus 36i squared. But I'm really going to think about that as a positive 36 because I squared is minus 1, so it changes the sign on that minus 36. So I end up with minus 24 plus 36 would give me a real part of 12, and I end up with 84i. Alright, one more on this board anyway, and I've got some more after that. So I could multiply these 2 together the same way, but I realize that they're complex conjugates. The only difference between them is that sign in the middle. So I know I'll just end up with a squared plus b squared. So I'll have 4 plus 49, and just end up with 53. So we're through the first 4 problems I wanted to do. Here are the next 4. And the instructions still simply could be perform the indicated operations. Got a couple division problems, and then I have a few problems here dealing with some negatives under radicals. To divide these 2 complex numbers, I'll need to multiply top and bottom by the conjugate of the bottom. So on the bottom I end up with that a squared plus b squared, 9 plus 4, so I'll have a 13 on the bottom when I'm all done. And now I can distribute this minus 6i through this set of parentheses. So I'd end up with a minus 18i and a plus 12i squared. And so that's really a minus 12. So when I do the division, I'd have a 13 on the bottom, so I'd have a minus 12 over 13 minus 18 over 13i. And that's my final answer there. Alright, another division problem, another multiply by the conjugate of the bottom. And of course when I say that I have to do the same thing to the top and bottom of that fraction. On the bottom I end up with 16 plus 9, so I end up with 25 on the bottom. On top I need to distribute 12 minus 9i minus 16i, and then on the end I have a plus 12i squared. Well, looking at it, I have 12 minus 12, those cancel. On the bottom I have 25. On the top I have minus 25i, which simplifies just to minus I. That one works out really nicely. Alright, so now I have to deal with some negatives under a radical. So in this one I think I'll start just by remembering that that means there's going to be an I involved. So that's I times the square root of 9, which is just 3i. So I have minus 5 minus 3i squared. Well, I could write that beside itself and multiply it, but I think I'll just remember my special product formula. 5 minus 5 squared is 25. In the middle, I'd multiply those together and then double it. So I'd end up with plus 30i. And then finally on the end, I'd have plus 9i squared. 25 minus 9 is 16 plus 30i. And just one more problem on this set and then two more problems out of section 2.1 to go. So on this one, I have minus 12 plus I times the square root of 28. We're going to get that minus out of there, write it as an I. All over 32. Well, I notice that 28 is 7 times 4. So I could rewrite that as minus 12 plus I times 2 square roots of 7, all over 32. To write it in standard form, I need to actually do the division. I could use just a little more room, so I'm going to cheat and use the board below. Here in a minute, minus 12 over 32 plus I times 2 root 7 over 32. And now we get to reduce our fractions. Both of these values are divisible by 4. I end up with minus 3 over 8 plus I root 7 over 16. And that's our final answer. All right, we've gotten through problem 38. That leaves two more I wanted to do out of this section during this video, number 49 and number 61. Problem number 49 asks us to solve a quadratic equation. I'm given 3x squared equals 8x minus 7. Well, the first thing I'm going to do is rewrite it so that I have this quadratic equal to 0. So I'm going to subtract everything to the other side. And now I can use the quadratic formula. The opposite of b, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. Alright, looking under the radical, I have 4 times 3 times 7 there, so I have 12 times 7 is 84. 64 minus 84, I have a minus 20 under the radical, all divided by 6. Rewrite that with an I in it. I end up with 8 plus or minus I root 20. But I times the square root of 20 is really 2 root 5. Because 20 is 4 times 5, the square root of 4 is 2. Still divided by 6. If I would put this in its standard form, I need to do the division. So I end up with 4/3 plus or minus I times root 5 over 3. If I wanted to write this down as two separate solutions, I certainly could. Alright, one more problem out of section 2.1 that I wanted to do today, and that was number 61. Number 61 asks us to use complex numbers in an application question. Complex numbers are used in electronics to describe the current in an electrical circuit. Ohm's law relates the current in a circuit, I, in amperes, the voltage of the circuit, E, in volts, and the resistance of the circuit, R, in ohms, by the formula E equals I times R. This textbook is the only one I've ever seen write it with an E. I'm not saying it doesn't happen, but most of the time I've seen it V equals IR, where V is the voltage, the electrical current. The voltage. But it doesn't really matter. We'll continue. Number 61 says, find E the voltage if I is 4 minus 5 I amps, and the resistance is 3 plus 7I ohms. So we're just given a current, 4 minus 5I, and the units here are amps. R, the resistance, is 3 plus 7I ohms. This formula says to find the voltage, I just multiply them together. So we don't really have to know anything about why this is true or what Ohm's law is saying. That was a very interesting thing to learn about. We can just multiply these two complex numbers. So I end up with 12 plus 28I minus 15I minus 35I squared. Left off an I there. Minus 15I there in the middle. So let's see. That's a 12, really plus 35. That's a 47 in the real part. And then 28I minus 15I is plus 13I volts. And there's the voltage in that electric circuit.